In this video, I want to go through some of the different methods I use to create bolt holes in Fusion, um, and what you need to do to accommodate for hole tolerances when you're designing parts for laser cutting or 3D printing. So to get started, let me open up a new sketch. And let's say I'm designing a simple part that looks like a slot shape like this, is 1 inch wide, and this dimension is 2 inches. And then we'll say this part is going to have 3 holes on it. So for the first hole, let's say this is going to be an exact known dimension. Maybe it's for an axle that's already precision cut to be 1/4 inch across. For that, we can just use the dimension tool and set the dimension to our known value. For the middle hole, let's say that's a clearance hole for a bolt. A clearance hole will need to be slightly oversized. So if we're making this a 1/4 bolt, it needs to be more than 1/4 inch so the bolt will go in smoothly. So to find out the dimension we want for this, I'm going to pull up a bolt sizing chart. You can easily find these by searching on the internet. This is one that I personally like to use. So here you can see an inch chart and a metric chart. So I said I wanted a 1/4 inch bolt. So that's this row here. You'll see it has 2 numbers, one for a close fit and one for a free fit. Close fit will just be a little more snug, so your part can't move around as much. Standard fit or a free fit will have a little bit more tolerance, makes it easier to line the bolt up. Usually I'm using a free fit. So for a quarter inch, that is 0.266. I'll swap back to Fusion and make this 0.266. Now the third hole, let's say we want it to be a tapped hole. So this is one that we're going to, after it's manufactured and drilled, go and run a tap through to cut threads in, so a bolt will thread into it. To get the size for this, again, I'll pull up that chart. You can see for the tap drill, there's a lot more numbers. You'll have to pick based on what thread pitch you're using. So standard 1/4 inch coarse thread would be 1/4 20. But if you're using fine threads, the numbers will be slightly different. It also depends what material you're using. So aluminum and soft metals will have smaller holes, so the threads are deeper, where steel or harder metals will have a larger hole, so the threads don't have to cut as deep. So let's say this is going to be aluminum, 1/4 20. That means we need a drill size of 0.201. So going back to Fusion, make this 0.201. Finish the sketch. And I'll just extrude this up by 1/4 inch. So this part has the correct hole sizes. So if we made an engineering drawing of this and sent it to be machined, the holes would come out the right size for an exact fit, a bolt clearance hole, and a bolt tapped hole. If we're going to send this to be laser cut, we need to make a couple adjustments to accommodate for the tolerances of the machine. So for example, one company I use says their tolerance is plus or minus 0.01 inches. So we'll need to accommodate that in this file before we send it out. So what I like to do is open up my parameters table and create a parameter defining what that tolerance number is. So I'll create a new parameter. I'm going to call it laser offset. And this specific service has a plus or minus 0.01 inch tolerance. So right now this first hole is exactly 1/4 inch. If we want something like a 1/4 inch axle to smoothly fit through this, right when we get this part back, we'll want to oversize this hole slightly using that tolerance to make sure that the hole doesn't come out too small. So I can use this offset face command to select this face and move it by negative laser offset. You can see if you zoom in there, that moved the face bigger by that amount. So this way the hole minimum would come out to 1/4 inch and maximum would be 1/4 inch plus the tolerance range. If we wanted this to be a press fit or a very exact number, I would instead do this the other way. I'd make it smaller by the offset and then plan on drilling or reaming this hole out to the exact size. But for this demo, I will leave that as a negative number, make the hole slightly larger. For the clearance hole, the sizing charts for bolts are already accommodating for some small tolerances. So when the laser cutting process only has 0.01 inch offset, this one can just be left alone. 0.266 is about the same as 1/4 inch plus the tolerances already. So we'll leave that one alone. The tapped hole, again, is from the sizing chart, so it's usually fine to leave that as is. I would recommend drilling the holes out to make sure they're not undersized before you run the tap through. Otherwise, you might end up breaking the tap you're using. If you're worried about them coming out oversized, it isn't a bad idea to go on these and make them smaller by the laser offset, and then just plan to drill them out, and that'll ensure that they're the correct size for tapping every time. Now let's say that instead of laser cutting this part, I wanted to 3D print it. 3D printing will need to make a few more changes to this part because the tolerances on that are even less exact than with the laser cutting. So I'm going to delete these offsets we created and start from the left again. So for the exact size hole, you'll almost always need to oversize it. 3D printing holes almost always come out smaller than you plan. The closest way I found to estimate this is that you need to offset the faces by half of the nozzle diameter you're using. Usually gets you pretty close. Now, depending on your printer and how it's calibrated, that might not be exactly correct, and you can run some testing and figure out what the number is for you. But for my printer, I'm going to change parameters again. I'll create another parameter for printer offset. And I'm usually printing on a standard 0.4 millimeter nozzle FDM printer. So I'll change my units to millimeters and make my offset 0.2, half of the nozzle diameter. So for the exact size hole, I'll again use the offset face command. And I'll make this bigger, so negative printer offset. With the number I'm using for my printer, I found that this comes out very close to the size that you want. This can mean that this can be a somewhat tight press fit sometimes, so you may need to offset it even farther if you want it to move smoothly. For the clearance hole, I'll also offset it to make it larger. So negative printer offset. If I've found that if you don't do this, even if you size this hole as a free fit, it comes out more like a close fit and even smaller than that sometimes, and it can be very hard to get the bolt to go through, especially if you're lining up multiple parts. So I'll always make clearance holes bigger by the printer offset. For the tapped hole, if I was going to actually tap the part after printing it, I would just leave it as is and drill it out. However, a lot of times when I'm printing, I'll take advantage of the 3D printer's capabilities and actually print this hole pre-threaded. So if you want to take a hole and make it threaded, there's an option under Create Thread. And if you use that, you can select this interface and go through and pick out what type of threads you want, what size. So I want 1/4 inch, what pitch. So I'll use a 1/4-20, which is a standard coarse thread. And then if you're planning to 3D print this, check this modeled box. And that will make it actually model those threads in your part. So if I zoom in on this thread, This is a precisely modeled thread as how you want it to come out, but it doesn't account for the shrinking effect of 3D printing. So if you're printing threads, it's often helpful to use that offset face command to go and select all 4 faces of the thread and offset those to make the hole slightly larger and the thread slightly wider. Now sometimes I'll skip this step, I'll leave it at it as is, and usually I can get the thread to cut into the plastic and it'll thread fine. Otherwise, you can try making it a little bit larger, usually using the full printer offset we defined as too much. So I might say instead negative printer offset divided by 2. And that just makes the threads a little bit bigger, so it'll be easier to get the screw to go in once it's printed. Fusion also provides a bolt hole creation tool that helps automate some of these steps for creating these clearance holes or threaded holes. So I'll go through that really quickly as well. So I'll start by just deleting off these modifications we made, and then I'll go to my extrude. I'm going to make it extrude these two so that we can create the holes with the hole tool instead. And I'm also going to make this extrude a little farther so I can show the options for countersinking. And then I'm going to go on my tree and show my sketch so I can see where those points were. So the hole tool is available in this Create panel. And what it will let you do is select a point in your sketch and convert that into a hole. So some of the options on the right, you can change how far you want it to drill. So either typing in a number, or you can select another face you want it to drill to. So in this case, I'll select the back of my part. You can change, at this middle row, you can change what type of hole. So it can be a simple hole with just a specified diameter. So that'd be like our first hole we did. Or you can choose a clearance or a tapped hole right from here. So if I choose clearance, it'll give me some more options to select what type of fastener I want to accommodate. So we were using 1/4-20 bolts, so I'll say ANSI unified screw threads, so those are imperial unit screws. What type of fastener head you have, so that mainly matters if you want a socket head screw, because that'll have a smaller counter bore, or just a normal hex head bolt, which has a larger, shallower counter bore. You pick your size, so 1/4 inch, and then the fit drop down will let you specify whether you want the normal fit or you want it closer or looser than standard. For laser cutting, I'd probably choose normal. For 3D printing, maybe choose loose so it has a little bit more clearance. So let's say loose. Some other options up here, you can change how you want the drill point to look. So by default, it's more of a cone. So this would be the actual shape that got drilled if you drilled this with a drill bit. If you're doing a through hole like this, or you're doing something for laser cutting or 3D printing where you're not going to drill the hole, then you can change this to flat to get rid of that cone. And then the first row lets you turn on if you want it to have a counter bore or a countersink. When you select this, it might reset your thread size, so I'll just quickly go through and set that back to what I wanted. And you can see it automatically generated a counter bore for a socket head 1/4 inch bolt. And countersink is similar. Again, I'll have to reset my values. And this will make an angled countersink if you're using a flush style screw head. So if you're designing a part that needs a counter bore or a countersink on bolts, the hole tool can be a much faster way to add holes than drawing the circles manually and looking up sizes in a table. Now for the threaded hole, we can use the same hole tool, select it, turn off the counter bore, switch the middle line here to tapped, and go set all our sizes again. And you can see here, like the thread tool, we have options for the thread pitch, right hand, left hand, and the option to make it modeled. So if you're designing this part to be laser cut, you could just leave modeled off, and this will size the hole to the correct drill size for tapping, although you may need to go and offset it depending on your tolerances. If you're doing it for 3D printing, you can check modeled to get that modeled thread. And then you may also, again, want to go and use an offset on those threaded faces to get them to thread in cleanly after they're 3D printed. So those are a few different methods you can use to create bolt holes in Fusion. You can create them manually by sketching out the circles. If you do, make sure you consult a tap drill chart to make sure you get the correct hole sizes for clearance holes or tapped holes. Or you can use the hole tool, which will automatically account for clearance holes and threaded holes, as well as give you options to create counter bores and modeled threads for 3D printing.